Okay, so in this last video we're going to talk about proportions, and let's just first talk about a ratio. A ratio compares quantities by division. Oops. And so a ratio might be, say if we were talking about the number of males in our class to females, we could say that the number of males in the class, there's one male, and let me get this, 7 females, so it's a ratio of 1 to 7, or we can write it as 1 to 7 or 1 over 7. And we're going to look at it this way, and it's comparing quantities by division. A proportion is a statement that says two ratios are equal. So we can think of that in terms of, we could rewrite this as, let's say if we had, based on this ratio, if we had 14 students in the class, then we would expect there to be approximately 2 males. So you can see that these ratios are equal, and I just did that by doubling. 7 times 2 is 14, 1 times 2 is 2. So this right here is a proportion. So let's say 5 over 6 is equal to 30 over 36. Again, another proportion, showing that these two ratios are equal. We use proportions for solving application problems, and first let's talk about how we would use the cross product principle when we're actually solving proportions. So if you think about let's say we have a proportion that said A over B is equal to C over D. So if we were solving this, if we wanted to find if we wanted to remove the denominators here, I could multiply this side times b, and my b's would cancel, multiply this side times b, because just as we saw in the previous video, if you multiply one side of an equation with a value, you have to multiply the other side in order to be consistent and keep your equations equal. So then to remove the denominator here, I could multiply this side by d, canceling these out. And then if I multiply that right-hand side by d, I have to multiply this left-hand side by d. And so what we end up with is that AD is equal to BC. And this is the cross-product principle for proportions. And if you look back at the original portion we had, if we say that A over B is equal to C over D, then we also know it's true that A times D is equal to B times C. And you can see that I proved that over here just by using algebra that we use to solve our equations with. So the cross product principle says that if you have a proportion A over B is equal to C over D, then you can set their cross products equal to each other. And this only works if it's a proportion, meaning there's one ratio set equal to the other ratio. This can't be used when you're adding fractions or anything like that, but the cross product principle works for proportions. Okay, so let's look at a couple of examples. So in this first example, we have 56 over x equals to 8 over 7. And this is one that you could do in your head, but sometimes it's easier just to do it using our cross product principle. So we have 56 times 7 equals to 8 times x. And now you simply have a linear equation. 56 times 7 is 392 equals to 8x. Divide both sides by 8, and x is going to be 49. And in this case, that's one you can actually see if you think about it, because 8 times 7 is 56, or 56 divided by 7 is 8, 49 divided by 7 is 7. But as you can see right here, they're not all that straightforward. So what we need to pay attention to here is sometimes we may have more than one term in our ratios. So if we multiply these, it's very important that you put your number in front of the parentheses. X minus 2 equals to 12 times 8. And hopefully you can see why I would do that. Because I'm not multiplying 3 just times the x, I'm multiplying 3 times the entire expression. So now I need to distribute. Going back to what we talked about in the previous video, talking about solving linear equations, you always want to simplify both sides before you start moving your variable term to one side and your constant term to the other. So this is going to give me 3x minus 6. 12 times 8 is 96. I need to remove the constant term or the numerical term, so I'm going to add 6 to both sides. It's going to give me 3x plus 0 is 102. And then this is 3 times 2, so the opposite operation or the inverse operation is division. If you divide the left-hand side by 3, you need to divide the right-hand side by 3. And when I do that, I get 34. And just like with linear equations, you can, of course, check these. So if I go back to my original problem and I wrote this as 34 minus 2 over 12, and does this equal to 8 over 3? 34 minus 2 is 32 over 12. And if I find my cross product, 12 times 8 is 96. And then 32 times 3 is indeed 96 as well. So 96 equals to 96. And so that makes for a true proportion. So our answer is indeed 34. Okay, so for number 3, I'll move this one up here. So for 3, this one has an algebraic expression in both ratios. So again, we just need to remember that when we write this, when we use our cross product principle, this is 2 times y plus 6, not just 2 times y. And then here, using my cross product principle, this is 3 times y minus 5. Simplify both sides. Now it's just an algebraic, just a linear equation, so we can distribute, giving me 2y plus 12 equals 3y minus 15. Move your constant terms to one side, so I'm going to remove the 3y here by subtracting 3y, performing the inverse operation there. If I have 2y and I subtract 3y, I'm going to be left with negative 1y, which you can write as negative 1y, but we don't leave it as negative 1. We would leave it just as negative y, but I'm going to leave that there actually for our final step. Don't forget, bring down this minus as a negative here. I'm going to subtract 12 from both sides because I'm performing the opposite or the inverse operations, and I'm left with negative 1y equals to a negative 27. And then divide by negative 1 because you're solving for y. You're not solving for a negative y, and that gives you a positive 27. Let's check that real quick. I'm going to have 2 over 27 minus 5, and the question is, does this equal to 3 over 27 plus 6? Okay, so, whoops. Crazy thing there. So that's going to be, my question is just 2 over 22 equal to 3 over 33. And I think you guys can see that these all reduce to 1 over 11. But just to check, we can use our cross product, and 2 times 33 is going to give me a 66. And 3 times 22 is also going to give me a 66. So we can be confident in our answer. Okay, solving applied problems using proportions. First, read the problem and represent the unknown quantity by x, or really any letter. I don't know if you've had a chance to watch the TED Talk that I posted in the previous notes. I guess I need to provide just a link to the TED Talk by itself, but it's in the notes from Tuesday if you're interested in checking that out on why we actually use x. Just an interesting little 4 minutes for you. Number 2, set up a proportion by listing the given ratio on one side and the ratio with the unknown quantity on the other side. Each respective quantity should occupy the same corresponding position on each side of the proportion. And this is very important. And it'll make more sense when we actually look at the problem. But it's just saying, make sure that your vertical values and your horizontal values correspond. And I'll show you an example of that. Number 3, drop the units and apply the cross products principle, and then solve for x and answer the question. Okay, so let's look at an example. We have an alligator's tail length is proportional to its body length. An alligator with a body length of 4 feet has a tail length of 3.6 feet. What is the tail length? So this is our unknown of an alligator whose body length is 6 feet. Okay, so x is our unknown, and this is our tail length. Whoops. Tail length, NGTH, of a 6 foot long alligator. So we're told these are proportional, so we can set up our proportion and we can make a relationship. So an alligator with a body length of 4 feet has a tail length of 3.6 feet. Okay, so this is the body and this is our tail. So we want to make sure that when we set up our ratio over here on the right with our unknown, that we put everything in its right place. So the body length was in the numerator, or the top of my ratio. So the body length of this alligator is 6 feet. And the tail length was 3.6. And so that's where our unknown goes. So that's what this previous problem, or the steps here, when it says each respective quantity should occupy the same corresponding position on each side of the proportion. So what that means is that oops, did it disappear on me? So that means that when I set up my proportion, as I said, the body over the tail must equal to the body over the tail. So that's our unknown. And it's very important that you correspond. So these two, the 4 and the 3.6, correspond because they're from the same alligator. The 4 and the 6 correspond because they're both the body length. And the 4 and the x have nothing to do with each other because the 4 is the body length of one triangle. Goodness. I'm not sure what's going on. I apologize for that. My pen is very sensitive, but you get to see this written a million times here, so maybe that'll help. So 4 feet body, 3.6 tail, 6 foot body. How long is that tail? So then we use our cross product principle, which tells me that 4x is equal to, and 3.6 times 6 is 21.6. So that's my cross product principle there. Now it's an equation, so we can divide both sides by 4. And x is going to be 5.4 feet. So the tail length of an alligator that is 6 feet long is going to be 5.4 feet. Okay, one more example. An object's weight on the moon is proportional, so we know we can set up a proportion. We need to create two ratios to its weight on Earth. Neil Armstrong, the first person to step on the moon on July 20th, 1969, weighed 360 pounds on Earth and 60 pounds on the moon. Of course, note that that's with all his equipment, because that's a lot otherwise. So, he was 360 pounds on Earth, but he was 60 pounds on the moon. And we want to know the moon weight of a person who weighs 160 pounds on Earth. So our unknown is the moon weight of a person that weighs 186 pounds on Earth. Okay, so we'll set up our ratio using what we know about Neil Armstrong. It's 360 pounds on the Earth and 60 pounds on the moon. So these two values relate because they're both about Neil Armstrong. Our unknown is our moon weight. So our moon weight was 60 pounds. So that's where our x is going to go here, and the 186 is how much they weigh on the Earth. So this corresponds to this because they're both our Earth weights. This corresponds to this because they both are from Neil Armstrong. That 360 and the x don't have anything to do with each other. These both relate to that person that's 186 pounds on the Earth. So Earth weight over moon weight, Earth weight over moon weight. We can use our cross product principle, and we get 360x equals to 60 times 186. When we do that, we get 11,160. solve this by dividing. This is 360 times x. We want to isolate that variable. So we divide and we get x is 31 pounds. And that makes sense if you look at it. 360, 60 is about 1/6 of that. 186, 31 is about 1/6 of that. So it's always good to go back and look at your problems and just make sure it makes sense. If you had ended up with this being 131 pounds, that wouldn't really make sense because it would be too close, and this relationship is not like that. All right, so by Tuesday, January 25th, please make sure you've watched these videos, and if you're here, then you have. And make sure you've read your syllabus, complete the syllabus verification form. Now you can work in MyMathLab on section 1.2, 6.1, and 6.2. Like I said, I'm going to extend the homework in 1.2 and 6.1 to Wednesday so that you can bring questions into class with you on Tuesday. I have attached the proportions lab in Moodle. Please make sure that you complete that to the best of your ability before you come to class on Tuesday. I will be taking them up, but I will answer questions, and you can also ask me questions via email. All right, I hope that helps, and sorry we missed out on class today, but hopefully you will feel comfortable with the content after watching these videos. Have a great weekend, and stay warm and safe.